Hi, my name is Markus Wieland, and I present on behalf of my co-authors the late-breaking work paper VR, Gaze and Visual Impairment, an exploratory study of the perception of eye contact across different sensory modalities for people with visual impairments in virtual reality. With our pronounced white sclera and the ability to follow gaze, we have the precondition to communicate via our eyes. But what means eye contact for people with visual impairments? Of course, eye contact is difficult to perceive and they rely on other sensory modalities to compensate. But this can lead to disadvantages in conversations with sighted persons. For example, when they are in a conversation and they cannot perceive the gaze as a turn-taking signal, which also means not catching up with the speed of a conversation. Virtual reality offers in general design possibilities to enhance eye contact during a conversation in social virtual reality spaces, and therefore make the gaze perceivable for people with visual impairments. In order to make gaze perceivable, we designed 5 different gaze cues that indicate that the person with visual impairment have been watched at by an avatar across visual, auditory and tactile modality in VR. We performed a group discussion with 8 people with visual impairment and 11 people with visual impairment tested the initial gaze cue designs. On the left side, you see a picture of the VR scene, which is a coffee house-like setup with the realistic human avatar sitting opposite. And you also see the visual ray gaze cue, which consisted of a red-colored ray that extended from the avatar's eyes to below the participant's head in the scene and was displayed for a duration of 2 seconds. On the right side, you see a picture of the visual flash gaze cue, where the entire scene is briefly illuminated with white light for approximately half a second. Here, you hear the auditory earcon. We used a single chime and played it twice. Here, you can hear the auditory icon, which consisted of 2 successive tones used to represent a typical blink from a cartoon movie. And for the tactile gaze cue, we used the HTC Vive controller, which vibrated twice in succession. Participants rated on a Likert scale the 5 different gaze cue variants. On the left side, you see the rankings with visual ray rated as best, followed by the auditory earcon. On the right side, you see the variants favored by the participants. Each participant should choose 1 variant. 7 people chose the visual ray and 2 people the auditory earcon and tactile cue. In summary, during the group discussion, it was revealed that people with visual impairments experience situations in which they are unable to perceive eye contact, leading to discomfort. This suggests the need for assistive gaze cues. In general, gaze cues are preferred that indicate the location of the conversation partner. Here, the visual ray gaze cue was rated best.